So let's talk about this measurement calculation that we're going to do in this week's lab. So when we do this in the lab, we literally have you put a ruler onto the stage. And let me make sure that you can see my pointer. So we literally put a ruler on the stage. And then so the first thing that people usually have trouble with is simply reading the ruler, right? So here's the inch scale, but you want to look at the millimeter scale. And what we're going to do is we're trying to figure out the size of something that you can't measure, like a paramecium, which is in a micrometer size. Now these little divisions here, those are millimeters. So the big one is a centimeter. From 0 to 1, that's 1 centimeter. And there's 10 millimeters in between there. And what we want to measure is things that are in micrometers. So 1 millimeter is 1,000 micrometers. We're going to calculate with that. So make sure that you're aware of what these things mean. Oops, now if I could change this next slide. All right, so the space between each hash mark is 1 millimeter. And what you can see under the microscope, turns out you see just basically one hash mark, and you can imagine that the next hash mark is right over there. So if this is 1 millimeter, then this is 2 millimeters. So on low power, the diameter of the field is 2 millimeters. Now we're going to try to figure out what the diameter of the field of view is at high power. So your first question is, what is the diameter of the field of view at low power, which is right here, and that's going to be the question that you're going to be asked on the next slide. Then we're going to do a bunch of calculations, and then at the end we're going to ask you about the size of the paramecium. So let's go to the next slide. So you already have the answer to the first question, right? Because you've already been told that the field of view at low power is 2 millimeters. So now the question is, how much is that in micrometers? And you know that 1,000 micrometers are 1 millimeter. So you should be able to figure out what that number is now. Now, the high power lens we can't measure because at low power, that's 10x. At low power, we only see one line, basically. There's no way we're going to see any lines or any divisions or make any estimations at 40x. And so this is why we're going to have to calculate this time. So to calculate the diameter of the high power field, you take the diameter of the low power field, magnify it by the low power, and then divide it by the magnification of the high power. So in this example, you're going to take whatever result you have from up here, right? You plug it in down here, multiply it by 100, divide it by 400, and whatever the result is, that's your answer. And because math is scary, we're going to take arrows to this so that you can take a look at this. So this number here is multiplied by 1,000 and goes in here. Then this number here gets transferred right there. You multiply it by 100, you divide it by 400, and then you get your answer in micrometers. Now, this answer here tells you what the diameter of this whole field is. So whatever comes out here is the answer. That's the diameter of the whole field. Now, clearly, the paramecium doesn't cover the whole field. And so then from there, I want you to just simply estimate what the length and the width of the paramecium may be. I hope that makes a little more sense.